Hello viewers, thanks for your support. In our channel, we are continuously discussing about concept behind fire protection engineering. Today also we are going to discuss one interesting topic. Let's see, let's move. This is the topic today. Why NFPA 13 not restrict the velocity of fire water? This topic related to hydraulic calculation. During the time of run the hydraulic calculation, many engineers having this question: what is the maximum limit of velocity, as mentioned in NFPA 13? So we are going to find the answer for this question. Prior to find the answer, as usual, we need to know, we need to understand some technical informations so related to this topic. So that is first one, velocity. So velocity is nothing, it's just a time and displacement of fluid. Usually it is expressed as meter per second. Then the total pressure. So the fluid passes through the cross sectional area or pipe. So whenever under non-flow condition, so the pressure will act on the inside wall of the pipe. So this is called static pressure or normal pressure. Whenever under flow conditions, the pressure will act on the flow direction. This is called velocity pressure. So if we want to calculate the total pressure, we need to add both. So static pressure plus velocity pressure is equal to total pressure. So next is Bernoulli's equation. So the Bernoulli's equation says, so if your pipe size increase, the velocity will decrease. If your pipe size decrease, the velocity will increase. So this is what Bernoulli's theorem says about the relationship between the pipe size and velocity. So next one, how to calculate the proper pipe size, how size the pipe. So the formula is there, Q is equal to area into velocity. The area will be expressed as pi by 4 d square into velocity. So this is a formula. So for let's take for the example, we are going to find the proper pipe size for these values, 1000 liter per minute and 4 meter per second velocity. So for mathematical derivative purpose, I change the formula like this. So d square is equal to 4 divided by pi multiplied by flow divided by velocity. So after I applied all values here, so I got the answer 71 mm. So this is the idea of the pipe. So which means 1000 liter per minute fire water at 4 meter per second means, so we need, it passes at 4 meter per second means we need 71 mm id of the pipe. So this is a proper pipe size as per market availability. Let's say this value will, the pipe size will be 3 inch. So this is a 3 inch is a proper pipe size. So instead of 3 inch we are putting 6 inch means what will happen? So putting 6 inch will decrease the velocity. So decreasing velocity, what will happen? Decreasing velocity, we cannot get the proper outlet pressure at the discharge outlets. So so instead of 3 inch, we are putting 1 inch means decreasing pipe size. Then what will happen? So decreasing pipe size will increase the velocity. So if velocity increases, what will happen? The velocity increases, it is simultaneously increase the pressure friction loss. So here you can see the image. Based on the velocity, the friction also will increase. Friction loss also will increase. So if friction loss will increase means, so what will happen? Based on the friction loss, pressure requirement at the source will also increase. So here the source means we are source means most of the time we are point the fire pump. So it will increase the fire pump pressure. So if fire pump pressure, requirement of fire pump pressure increase means the fire pump cost also will increase, and also pipes and fittings and walls pressure ratings also will increase, because such items, pipes, walls and fittings pressure rating decided based on the shut-off pressure of pump. So that is also will increase. So this is totally will increase the project cost. So we need to put the proper size of the pipe. Otherwise, the design issues will come. The if you are decreasing pipe size means the pump pressure will increase, so the cost will increase. So then come back to the question, why NFPA 13 not restrict the velocity of fire water? So the answer is, so when the velocity will increase, So if you are decrease the pipe, then only the velocity will increase. If you are putting proper pipe size means, then how the velocity will increase? It will not increase. So as of my experience, in one hydraulic calculation, mistakenly I put 1 inch pipe instead of 6 inch. So after run the calculation, I so I note, so the velocity in particular point, the velocity will be more than 500 meter per second, and the source pressure requirement is more than 30 bar. So you can imagine the maximum listed fire pump pressure availability in the world is 294 psi. So if it is pressure more than 30 bar means, so it is not part this is not practical to, this is not practical. So what I'm trying to convey here means, so if you are if you are if you want to adjust your pressure, if you feel your pressure, your source pressure will increase high, so if you want to try to adjust or correct the pressure means, you will adjust the pipe size. So if you are adjust the pipe size means, it will automatically, the velocity will come to normal number, so it will not go more than high. So this is a reason NFA 13 not restrict the velocity of fire water. So I hope everyone understand this video. If you have any clarifications, please put on comment section. Definitely I will reply you. uh, Thanks for your support. I reached 100 subscribers.